Hello everyone, welcome back to my channel and pardon me for uploading the second part of binomial series video so late. I am going to be a little more regular now with uploading the videos and let's get on to this quickly. Yes, in the previous video we had looked at everything that is related to binomial expansion starting from the basics. Then we looked at something like this where a triangle shape was formed and we were able to identify what are the coefficients of expansion, right? So I had left the previous video on a cliffhanger by saying that a plus b the whole raised to n, is there a formula? Yes, there is a formula, and no doubt we can use the triangle method also. Let me give a name to that triangle method. That method, the one that we used, is called Pascal's triangle. So whatever the value of n be, where n is the power of the binomial expansion, whatever the value of n be, we can use the Pascal's triangle method. We can draw that triangle to whatever value they have asked us to go up to. Let's say if they have asked us to go for a plus b the whole raised to 5, let's say, which means I have to go until I reach 5. So this is for power 1. For power 2, you add them and you get 1 to 1. You add them, you get 3. You add them, you get 3 again. That's again 1, 3, 3, 1. You add them, you get 4. That's 6. That's 4. And in the end, we have 1. If you add them further, you get 5, 10, 10, 5. And towards the end, you will write the ones. This is for power 5, which means the basic coefficients of a plus b the whole raised to 5 are going to be 1, 5, 10, 10, 5, 1. Okay. So now that we know what are the basic coefficients, we are going to look at not only this method but also another method which is called the formula method. What is the formula method? For that, obviously, if we call something as formula method, we need to have a formula for the same, which is where we had stopped in the previous video. So let's look at how the formula is formed. Yeah, based on our observations in the previous videos. Let me go back to the previous. Yeah. If you look at this, the power of a goes on decreasing. Yes, and the power of b goes on increasing until it reaches the maximum value, right? So 5, 4, 3, 2, 1, and nothing over here means power is 0, and 1, 2, 3, 4, 5, which means if there's nothing over here, it means the power is 0. Okay, so we'll use that and we'll try to form the formula. Let's say if it is a plus b the whole raised to n, it starts with nc0 a raised to n b raised to 0 plus nc1 a raised to power reduces by 1 and power for b increases by 1. Then you have nc2 power reduces by 2, power increases by 1, right? Or increases by another 1, if we may say it that way. A raised to n minus 3, b raised to 3, and so on. This goes on. So until when will that go on? This will go on until you reach the last one where a raised to becomes 1, b raised to n minus 1, which is the second last term, and then you reach NCN, a raised to 0 and b raised to n. That's the ultimate formula. Yeah. So if you observe that formula, you will notice that the power of A, it goes on decreasing, yes, until it reaches 0, and the power of B starting from 0 goes on increasing until it reaches the maximum power, which is n. Okay, so this is the formula method, and in this formula method there is something called as NC0, NC1, NC2, NC3, yeah, and all of this, which means we need to know what is NC0, NC1, what is NCR basically. In general, you're going to learn this in permutation and combination, but just to give you a small gist or just an understanding of the formula is n factorial over n minus r factorial times r factorial. In case you don't know this, it's totally fine. You can use the calculator over here directly and substitute the values of n and c and 0, 1, 2, 3, whatever, and you will get your answers. Okay, so obviously we know now what are the different methods. Let's move on to understanding how it can be applied. Okay, so instead of talking too much, let us see how we can apply them. Let's go for it. Let's say I'm looking at the first one, and that's comparatively easy one. Okay, 1 minus x the whole raised to 9. If you were to use the Pascal's triangle method, then in the Pascal's triangle you will have to go up to 9th row, which is going to be a little too much, so let us try and expand it using the formula method that we just saw. Yes, let's say if we are looking at the formula method, what does the formula method say? It says NC0, and if I consider this as A and this as B, only along with the sign if I have to consider, then it becomes 1 raised to 9 times, I will consider it along with the sign, because my original formula, let me go back to the formula over here. My original formula is about A plus B the whole raised to n. Yes, it is about A plus B the whole raised to n. So we are not going to get into what will happen if it becomes minus. We are only going to understand this by saying that we'll take the negative sign with B and we'll write a plus over here. So it will be more like A plus minus B the whole raised to 9. Okay, so instead of the plus x, we'll put a minus x over there. Okay, plus 9c1 times 1 raised to 8 times minus x raised to 1 plus 9c2 times 1 raised to 7 times minus x raised to 2 plus 9c3 times 1 raised to 6 times minus x raised to 3, and so on. Now if I read this question, it says find the coefficient of x cube, which means I don't have to expand it beyond x cube. Don't you think I am going to reach x cube at this point only? So I don't have to expand it further. In exam also, please read the question carefully. Whatever coefficient they are asking, you expand it only till that value, not beyond that. Okay, perfect. Let's go. So 9c0 is going to be 1 times 1 raised to 9 is 1, and anything raised to 0 is also 1. So minus x the whole raised to 0 is also 1. Okay, moving on. 9c1 is going to be 9 times 1 times negative x. Now this negative sign, please be aware, negative sign when gets multiplied over here makes the whole term negative. Okay, what is 9c2 going to be? Let me do it with the calculator. When you do that with the calculator, you get 36. 9c2 is 36. Okay. Times 1 raised to 7 is 1 itself, and minus x square will become plus x squared. Plus, if I go to 9c3, it gives me 84 times 1 times negative x cube, because it is cubic, so the power is odd, which means the sign will be negative. Okay, that is 1, that makes it minus 9x, that makes it plus 36x squared. And what about this one? It will become minus 84x cube plus dot dot dot. Yeah. Now, what have they asked? Find the coefficient of x cube. So I am only going to be concerned with what is multiplied with x cube. So my final answer should be minus 84, because that is the coefficient of x cube. Okay, something as basic as this. So a lot of students, when we do this in class, they say, sir, you always solve the easy question, can you solve something that is a little difficult? So let's go on for something that looks a little difficult. Trust me, it is not difficult at all, but yes, I can understand that this looks a little difficult. So let's try to do the C1. Yeah, what does the C1 say over here? The C1 says 2 plus x over 4 the whole raised to 7. Yes, you're going to expand it until 7. But again, what are they asking? They're asking the coefficient of x cube. Okay, they are asking the coefficient of x cube, which means you have to expand only until x cube. Since this is the initial phase of binomial expansion, we are going to try and expand and find out the coefficient. Later on, when we are going to do some past paper style questions, I will also show you another trick by which you don't have to expand, you can directly find the coefficient. Okay, but we have to wait until we reach that stage. So for now, we are going to stick to the basics and we are going to try and apply the formula. Okay, if you wish not to apply the formula, then let's try the Pascal triangle method also over here. Yes, let's try the Pascal triangle method. The Pascal triangle, I'm going to start a little higher up. This becomes 1 to 1. I'm sorry, I'm writing a little smaller so that I can reach 7 easily. Yeah, 1, 5, 10, 10, 5, 1. That's the row of 5. Then you have 6. Then you have 15. That's 20. That's 15 again. That's 6 and ends with 1. We're almost there. Hold on, guys. Hold on. So 1 plus 6, 7. 15 plus 6, 9. 15 plus 6 is 21. This is 35. This is 35 again. This is 21. And that's 7 to end with 7. Okay. Which means when I'm going to expand, first term will have coefficient 1. Second term will have coefficient 7. Third term will have coefficient 21. And so on and so forth. Yes. Which means, let's go for it. Which means, if I were to expand this, this would be, I can, instead of writing 7c0, I can write 1 directly and I will say 2 raised to 7, because if that is my A and that is my B, and obviously there is a plus sign, we don't have to worry about anything now. A plus B the whole raised to 7. So it is A raised to 7. It starts with A raised to 7. Highest power given to A first. Okay. And B is raised to 0. So I'm not going to write anything about it. Okay. Second term should have coefficient 7. I will directly write 7 over here. Times 2 raised to 6 times x by 4 the whole raised to 1. Okay. Plus next one should have coefficient 21. 21 times 2 raised to 5 times x by 4 the whole raised to 2. the power 4x by 4 keeps on increasing. The next one should have 35. So 35 times 2 raised to 4 times x by 4 the whole raised to 3 plus dot 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 dot. Okay, so now my concern is all of this. So I am going to highlight all of this and I am going to focus on that only. Let's look at that. That's going to be 35 times 2 raised to 4 times x cube over 4 raised to 3. Can I call it 64? Yes. For the ease of understanding and calculation, 35 times 2 raised to 4 is 16, guys. And that's x cube over 64. 16 ones are, 16 fours are. So 35 over 4 times x cube. What did they want? The answer that they were expecting was coefficient of x cube. Don't you think that should be my answer? So I'm going to write the answer here just to highlight that it is going to be coefficient of x cube is 35 over 4. Remember, in the final board exams, this is the kind of working that is expected to be shown. Now, obviously, do we have to show each and every term expansion? Not necessary. As I said previously, that we are not going to do expansion until we reach that particular term. We are going to purely try and understand what is a shortcut to reach that thing. Okay, but until then you should have at least solved, or you should have done at least 10 to 20 binomial expansion, basic expansion only. If you have done that much, then you will be good to go to understand the logic for that particular shortcut. Okay, perfect. So are we good over here? I think this makes it a little more clearer as to how we can use the Pascal triangle method also, and how we can use the formula method also, right? Perfect. I think for homework, I think you all should try D and B. See, sometimes I give easier questions also for homework. Yes, and sometimes I give a little more difficult questions as well. Yes. Perfect. Thank you so much. Thank you so much for watching this and being patient in waiting for the next video. The next video for binomial expansion will be coming up soon. It will be purely based on past paper solving, just to give you a glimpse of what kind of past papers you see. Find the coefficient of expansion of so and so. Just imagine the kind of difficulty level that we are going to attack or hit in the next video is going to be amazing. Yes. Oh, that was a trailer. Okay. Bye bye. Thank you.